First, rusting of iron. So basically, what is a rust? It is a formation of hydrated iron oxide So formation of red brown hydrated iron oxide on the surface of iron is known as rust. And what happened, like why when rusting of iron occur? When rusting for iron occur, it reduces the strength of iron. What's the reason for that? Like some metals, when the rusting occur, like not rusting, like oxide layer, the protective oxide layer, but that does not happen for iron. For iron, what happen when the rusting occur? Like example, you have a piece of iron. So this is a piece of iron, and it react with oxygen in the atmosphere and water vapors, water molecule. When we say hydrated compound, the term hydrated compound means that it should have water molecules as well. So when iron react with oxygen, it will form iron oxide. And when this water vapors are there, then it will form hydrated iron oxide. Means what will be the compound formula of this compound? If we say iron is there reacting with oxygen, and water molecules, this will result in a formation of iron oxide, Fe2O3, dot XH2O. Means the water molecule can have a variable percentage. This can be any number here for water. That's why I wrote X. Like if water molecules are 3, then it will be 3H2. If it's 5, according to that, variation is there. It's not a fixed number. This compound, which is iron oxide and also traps some water molecule, we call this as hydrated iron 3 oxide, and this is a formula for rust. So when this reaction occurs, the surface of the iron will turn red brown due to this chemical reaction. And this will reduce the strength of iron. How it reduces the strength of iron? Because this hydrated iron oxide does not remain in contact with iron. It's a flaky substance, so it will tear off from the surface, remove from the surface. Like example, if you have an object which hydrated iron oxide is formed, So this hydrated iron oxide or a rusting occur. If you touch an object, what happens? This layer is easily, it's a flaky substance. This layer is easily removed. So as this layer is easily removed, then what happened? This hydrated iron oxide layer is removed. Now the other part of iron is exposed. The part of iron is rusted and that is removed from the iron surface. Now the other part is now exposed to the atmosphere. That will also develop an oxide layer, hydrated iron oxide layer, and that will also rust. Then this layer also tear or peel off from the surface. So what it is doing, it is reducing the strength of iron. And you will have a time when you are not left with any iron. All the iron is converted into hydrated iron oxide. So that's why rusting of iron reduces the strength of the iron. Is it clear, the concept of rusting? Any doubt in this part till now? Then this rusting is a redox reaction. Why we call that as a redox reaction? The term redox reaction means, the term reduction means gain of electron, and oxidation means loss of electron. So in this reaction, which substance is losing electron, which substance is gaining electron? Because iron is a metal. So what is the tendency of the metal? Metal tend to lose electron. Hydrated iron oxide cannot be reverted back to iron. Iron oxide can be, but hydrated iron oxide cannot be converted back to iron. Otherwise, it will not cause any, like, we don't use the methods to prevent rusting because it's not a reverse synthesis cannot be done. Like if you have a rust and you cannot extract the iron from the rust, so it's not possible to extract the iron from the rust. So metal, iron is a metal, it tends to lose electron, where oxygen is a non-metal, it tends to gain electron. That's why we call that as a redox reaction. Iron will lose electron and oxygen will gain electron from iron. So we call this reaction as a redox reaction. Is it clear, the formation of the rust? The formation of a red-brown hydrated iron oxide on the surface of iron is known as rusting of iron, or also you can say corrosion occur. And what is the effect of this? Because hydrated iron oxide does not remain in contact with the iron, so it can easily remove, it's a flaky substance, easily removed from the surface of the iron, and the other parts of iron are exposed to oxygen and water, so which will cause rusting to occur. Any doubt in this part? The equation here, iron reacting with oxygen. When iron is reacting with oxygen, it will form iron oxide, iron 3 oxide, Fe2O3. But for rusting to occur, because rust is hydrated iron oxide, normal iron oxide is Fe2O3, or it can be FeO, iron 2 oxide or iron 3. These are normal. But what is a rust? Rust is iron oxide which also contain water molecules. X water molecule. Here, what is the meaning of X? X means it can be any number. It can have 5 water molecules, 10 water molecules. and which, when it is forming, it reduces the strength of the iron. Any doubt in this part? Now, how we can prevent rusting? Before preventing a rusting, a simple experiment to show. Both oxygen and water are reactants for rusting of iron. So how we can carry out this experiment? So we can take 4 containers. In first container, all the containers, we take iron nails, equal size and masses of the iron nail. And rusting is a slow process, so it takes time to for a rusting of iron. It's not a fast process. So the apparatus must be left, like example, for a week or 2 weeks to observe that rusting happen. So we take equal size, equal mass of iron nails. In a first container, we put a dry air. In the second container, we put a boiled water. In the third container, we put oil. And in the last container, we put tap water. So the one which is with the dry air, it means it contain oxygen is there, but there is no water because it's a dry air. So we remove the water vapors. The one which is boiled water, because when you boil the water, you remove the oxygen because water contain dissolved oxygen. That's why when we are boiling a water, we see bubbles are coming out. Dissolved air is there basically. So that when we boil the water, that air is removed from the water. So it does not contain oxygen, but there is water. Oil, we dipped in oil, so air, there is no air, dissolved air in this oil. So there is no oxygen and there is no water vapors or water molecules. The tap water contain oxygen. The dissolved air is there, because of that oxygen is there and water is already there. It's a tap water. So if we leave the apparatus for 2 weeks, which one will observe formation of the red brown layer? A, B, C, or D? So rusting is a slow process. So if we leave them, for example, a week or 2 weeks, so we will observe a formation of the red brown layer formed on the iron nail in D. So this experiment, this is a simple experiment. It proves that for rusting to occur, both oxygen and water are the reactants. It means rusting cannot occur if you have environment only oxygen. Rusting cannot occur if you have environment only water. You should have both oxygen and water for rusting to occur. And how we can prevent rusting? So this simple experiment shows that for rusting of iron, we need both oxygen and water. How we can prevent rusting? Methods to prevent rusting of iron. Number one, we can paint. Because what happened, the paint, and normally, which case we use paint? We normally use paint for large structures. So like such as bridges, we use this paint to prevent iron from rusting. Like if the whole structure is made up of iron, what's the advantage of painting this? If you have a piece of iron, so if you have iron, and when you paint, so the layer of a paint which stick to the surface of the iron prevent this iron from rusting. How it prevent iron from rusting? Because it is not allowing any interaction of oxygen and water vapors from the atmosphere. So as it is preventing oxygen and water vapors from the atmosphere to react with iron, so the iron will not rust. But what happen, like if an object, if the structure or if the surface is used for a longer period of a time, so the layer of the paint might be tear off or peel off. So in that case, we have to repaint it again. Is it clear how rusting is prevented by painting the object? The second thing which we can do to prevent iron from rusting, we can, yes, by greasing, by putting oil. By oiling or greasing. What's the meaning? This normally used for moving parts. Moving parts, oil and grease will reduce the friction as well, and it is also preventing the rusting. Because, like example, you're adding to a car engine, you're adding an engine oil. So, what is the purpose of that engine oil? It is doing two things. It is reducing the friction between the parts inside the engine, as well as it is preventing rust. Because what happened, the same idea, that the parts inside the engine are moving and they normally come in contact with each other. So when they come in contact with each other, if you use a paint, because the two surfaces are continuously in contact with each other, so the paint might be scratch or peel off. So painting will not be suitable. That's why for moving parts, whenever parts are moving, what we use oiling and oil or grease. So if you have a piece of iron, say iron is there, so two parts are in contact with each other. So what we do, we use oil or a grease to prevent rusting. The oil and the grease will reduce the friction between the parts, as well as, because this oil and grease will not allow the air to interact with piece of iron, so it will prevent rusting. So basically we have to protect the iron surface. So if we are able to protect the iron surface, we are able to protect iron from rusting. This is the second way by which we can prevent iron from rusting. Then we can use electroplating. Electroplating means covering the surface of iron with less reactive metal, such as like silver is there, platinum is there. So any less reactive metal, so we can do electroplating. Say you have iron nail and you want to prevent this iron nail from rusting. Or you have a key, you want to prevent this key from rusting. So what you can do, you can electroplate. How electroplating can be done? The electrolysis chapter we discussed. So we will connect with a battery, the negative terminal. The cathode is the object which we want to plate, and anode is the material which we want a layer. Like example, if I need a silver layer, it should be made up of silver. If I need copper layer, it should be made up of copper. And the salt, the electrolyte should be a salt. So if I, example, I want silver plating. So this will be made up of silver, Ag, and the solution will contain silver ion and nitrate ion. So what happened? And it is aqueous, so hydrogen ion and hydroxide ion. For positive ion, always the less reactive will move towards cathode, the negative terminal. So silver ion will move towards cathode. So as silver ion will move towards cathode, so silver ion will gain electron and change into silver metal. So the layer of the silver deposited on this nail, and the part which is inside the solution will only get a layer, not the whole. So it should be completely immersed in the liquid, in the solution, so that completely it will be electroplated. And silver atom, as the amount of silver ion in the solution decrease, so silver atom will go inside the solution as a silver ion to balance this. So size of cathode will increase and size of anode will decrease. So this is how electroplating is done. Then there's also another method which we call galvanization. Galvanization means we plate with more reactive metal. Look what happened in electroplating. In electroplating, we use the concept of the same concept of electrolysis. The positive ions, what are the positive ions present? We have silver ion and we have hydrogen ion. So always the less reactive positive ion will move towards cathode. So when you compare the reactivity, silver is less reactive, so silver will move towards the cathode. As the silver ion will move towards cathode, it will take electrons from the cathode and stick to the surface of the key and it will deposit it on the surface. So this will have a silver layer. Now, as the silver ions are moving towards the cathode, so amount of silver ion in the solution decreases. So to overcome this, the silver atom from the anode will go inside the solution as a silver ion. So the size of the anode will decrease and the size of cathode will increase. This is called electroplating. So whenever you want electroplating, you use less reactive metal than hydrogen. The anode should be made up of that metal, and the solution, the electrolyte, also it's a salt of that metal. Is it clear? Then galvanization. Galvanization means coating with more reactive metal such as zinc. So if we cover the iron with a more reactive metal, we use this electroplating to prevent rusting of iron. These are the methods to prevent rusting of the iron. So if we coat with a more reactive metal, such as zinc, we call that as galvanization. Now, what is the advantage of galvanizing over electroplating? Like example, you have a piece of iron. Say this is a piece of iron, okay? And you cover, these are all methods to prevent rusting of iron. You want to prevent iron from rusting. And you coat it, you cover this surface of iron with zinc. So iron will not rust because it is protected by zinc. Now, what is the advantage of galvanizing over electroplating? Look, for example,